me. I will be asking questions with little. Okay. So we are doing a multiplier. I have already showed you 4-bit multiplication, in which I showed you that the first product of 1101 with this one will give you this. This is called as our partial product number 1. It will be called as partial product number 1. So I will call it as PP1. Then when you get your another 1101 into 1, this is your partial product number 2, which is kept with a shifting, because we all know we need to shift. Then when we need to add these two, because any adder is capable of adding two numbers only, and you get this your partial sum, you can say. So this is my partial sum number 1. Next, what do we do? After adding, we multiply this 0 with 1101 and you get your partial product 3. And again, we add our partial product 3 with the previous sum and we get our partial sum 2. And then what do? We have also taken care that we had shifted it 2 times, because shifting is most important in multiplication, as we have seen in our standard multiplication of decimal number also. Next, what do? We have to multiply our 4th bit to the multiplicand. So this multiplicand multiplying with this 1, but it is written with a 3 shift. So this is called as partial product number 4. And once we add, we get our final partial sum, that is 3. And then when we checked it, it came out to be 143, the way it is for your decimal multiplication. Now coming into this circuit. Now before you understand that, you have to see you have a 4-bit of multiplicand and a 4-bit of multiplier. So I have to see to keep this 4 bits of both the numbers. Also what you have to see is, you have to see the shifting is happening every time, right? Shifting is happening every time, but copying the same number of 1101 happens when your multiplier is having a 1. But the copying of 0 happens if your multiplier is having a 0. So whatever we get this as is called as mode M. Mode M. So mode M will take care whether you have to bring your multiplicand 1101 or you have to bring a 0000, because that is decided by the multiplier bit. Now you will understand with this, your multiplier is kept here. What was your multiplier? Multiplier was your second number. This one. Multiplier was your second number and multiplicand is your 1101. So what is happening? Your 1101 only is being added again and again and again, because all of you know that multiplier is what? Multiplier is a repeated addition. Multiplier is a repeated addition. So what you can see, your partial product number 1, 2 and 4 was the same number as multiplicand. I hope you have observed this. So multiplicand is being repetitively added at PP1 and at PP2 and at PP4. When your multiplicand was repetitively adding, whenever your multiplier bit used to be 1, and when it was being added to 00, when your multiplier bit was 0. So you have to see that your addition is nothing but repetitive addition of multiplicand only. Now let us come back here. So your multiplier 4 bits are kept here and your multiplicand 4 bit is kept at 4, 5, 6, 7. 4, 5, 6, 7 bit is for multiplicand and 0, 1, 2, 3 is for multiplier. And you can see a two-way arrow here, which is adding and giving back the result here only. Adding and giving back the result here only. Again, now you have to see that at the initial bit, okay, see initial content of the product register. What you see here, initial content of the product register is like this. So initial content means this 4, 5, 6, 7, 8 are kept vacant. It is kept at 0, 0, 0, 0. And your multiplier 4 bits are kept at last LSBs of the accumulator. So this accumulator is a 0 to 8, 9-bit accumulator it is. So your 0, 1, 2, 3 is having your multiplier. Now what is happening? You will see that how things are happening based upon the this bit. So what you saw when your first bit was 1, you had kept your 1101. So now you should okay, now let us see your this 1101 is coming here, right? Your 1101 is coming here, and what is there in this? It is same. So what you can see 1101 and 1011 is after addition it is kept like this. After that what happens? When your control circuit says load, it loads your in LSBs with multiplier 4 to 8 as 0, 0, and multiplicand is also loaded here. So after addition what happens? You get your this answer. And how this addition is happening? This addition is happening with these zeros, and this multiplicand. So the two numbers of the adder are coming from down and up. So addition happens here, and the result is fed back to bit number 4, 5, 6, 7. So initially content of the product register was this. When you added this, after addition, this was the result. After this, what happens? Your control circuit says that you shift it. Shift it means the complete thing shifts to right. So you can see here, you are shifting this thing to right. When you shift this thing to right, your this 1 multiplier first bit is gone. Gone why? Because work is already done, you do not need it anymore. Now based upon this LSB which comes here now, addition or no addition will happen. So when you see that M mode is 1, the multiplicand will be adding again 1101. And here you were shifting this as left. But here what is happening? Your bits remain same and this shifts to right. So it is bringing the same effect. It is bringing the same effect that your shift is happening because your product register itself is shifting by 1, right? This one shift is happening here. I hope you people are understanding. This shift, you see my mouse. This shift, what I have put a dash here, is happening here. This shift is happening. Why it is happening? Because the complete accumulator bits are only shifted 1 to the right. So after that what? Addition happens. When addition is happening, you get your answer like this. Again you shift, it shifts again, and then you are left with next one. Now when you see that 0, this 0 is there, no? After shifting, you get this mode as 0. When mode is 0, you skip addition. You do not do addition, you simply shift. Why you do not do addition? Because actually you were adding to 0, 0 only. So answer is same. But shifting is important in multiplication. So no addition, but shifting happens. When shifting happens, it goes like this. And then what happens? Then what happens? Your shifting happens, and for last m equal to 1, again your 1101 comes here, and again addition is happening, and again you shift it to right, and you get the same answer the way I got here, 100011111. So this is how this multiplier is being done using this circuit. Now you can see this circuit again. You can see this circuit again. So the job of the control circuit was first to start. As soon as it starts, loading happens. After loading, your addition happens for the 4 time, If there is a 0, addition does not happen, only shift happen. And this add signal says that it has to add. Because it is a sequential circuit, clock will be governing everything, because each operation happens in one clock cycle. Once 4 times shifting is done, then this done output signal says that done is equal to 1, and it shifts, it gives the final answer. Now you can understand this state graph also. You can see here what is happening. Your S0 is there, that is your initial state. Till your start is 0, it will remain here. As soon as start signal comes high, it loads. Loads what? It loads multiplier and multiplicand, and also 0 0 in bit number 4 to 8. Then what happens? If M is 1, addition happens and then shifting happens. If M is 0, directly shifting happens. I hope this part is clear. If M is 1, add and then shift. If M is 0, directly only shift. And this happens for the 4 time. So number 1, number 2, number 3, number 4. When 4 times this happens and it reaches the last but one state, it will give your done signal high and it goes to the initial state. So this is your state graph of multiplier control. Please remember that the state graph, whatever we are making, is for the control circuit only and not for addition and all. Okay, addition does not require sequential state graph, because addition is a combinational operation. So that is done, and the same states, because you have so many states, no, the same states are put here as this state transition table. Also you can see that we can make our state table. You can see here, no, we have so many states, S0 to S9 we have. But what can be done is, it is not good to have so many states, so we reduce the state reduction. So what it is showing here is, it is doing this work with only 4 states. Now let us understand this also. If it is S0, and start is 0, it remains here, and then start and load happens. So S0 to S1, no change. Only change is that this triangle, you can see na, this triangle was happening 4 times, and now we are doing that only 1 time, but it is repeated. It is repeated in what way? You can see here. It goes to M. If M is 1, it adds and it goes back to shift. It keeps on shifting at S1 with M0 without addition. If M is 1, it adds and come back to S1 with shifting. So the triangle is happening like this. Now what is this K? K will be the counter. Counter means what? If it is 4 bit, this K will become 1 only once this 4 bits are over. So till this 4 bits will be fed to a counter. Counter will count 1, 2, 3, 4. Once the counter reaches to the maximum, then the K bit will become high. So you can see here, counter is there. When K becomes high, so you can see only shifting with M equal to 0 happens here. If M is 1, adding and shifting happens all the time when K is 0. K is the bit counter control. As soon as you see that K is high, it will do the final shift, comes to S3. Even if M is 0 and K becomes high, it comes to the final S3 and makes comes to final S3 with the shifting, and this comes to final S3 with addition and shifting. So this is taking care of n bit multiplier also. When it comes to S3 bit, that means the complete multiplication has happened. So it goes to initial state with the done signal high. So this is called the state graph with the state reduction also. And then what happens? Your S0, S1, S2, S3 is written here. And they have shown it with one example, which you can also check after doing your revision as homework. of whatever I have taught you now. Okay, so try to understand this one example of the multiplier.